Hi, welcome everybody. My name is Andrew Burgess. Welcome to this talk, which is part of the STEMS Club Week 2023. So today I'm going to talk to you about how artificial intelligence is impacting the world of medicine and healthcare. First of all, I thought I'd tell you a little bit more about myself. So I'm a management consultant. I work in AI. I wrote a book recently called The Executive Guide to Artificial Intelligence, which was published a few years ago. I also do some lecturing at Loughborough University and as well at Imperial College in London, which is where I live. I also do work with the Natural History Museum, which is a fascinating client to have. As you can imagine, I'll talk a little bit more about that later on. Some of the clients that I work with, some of you may have heard of, so quite a few charities like Macmillan Cancer Support, Parkinson's UK and Prostate Cancer UK, and also some other businesses such as Direct Line and Compare the Market, who you may know from the Meerkat adverts that you see on TV all day. So that's a little bit about me. I thought I'd tell you one of the best things I think about my job before I kind of move into talk about artificial intelligence. My background, I did maths, physics and chemistry at A-levels. I did a degree in aeronautical engineering at Manchester University and was a management consultant most of my career, but more recently in the last 10 years or so I've been focusing on technology and particularly artificial intelligence. So a lot of the work I do, as I said, is helping companies to use artificial intelligence to the best abilities and to help manage some of the risks as well around AI. So some of the best things about that job, I think, are getting to work with some really interesting people, work with some important people, some cool people, some very, very clever people as well. All of them interesting, all with great stories, and I get to find out all about the work that they do and help them to use AI to help them do their jobs better. And I also get to work with some of the coolest technologies as well. So AI is really the one of the hottest topics at the moment in technology and generally in the world at the moment. Is making news headlines recently with all the talk about ChatGPT and Bard and Bing, etc. So I get to work in these kind of leading edge technologies, which I really love, and they're always changing. So I'm a very curious person. So as things change, it's just more and more stuff to learn, which is great. But I think the most important thing about doing this work with AI is I get to help people. So one of the things I'll talk about later is how we can use AI, but also some of the risks about AI. But a lot of the work I do is focusing on the good things that AI can do. So I talked about some of the charities that I do work with as well. So helping use AI to do good in the world, I think, is really, really important. And that's probably the most satisfying thing about my job, and how I use these STEM skills that I've developed over the years. So in this presentation, I'm going to ask a few questions to really test how clever AI is in the world of medicine and healthcare. And the first one I'm going to ask is, can AI predict the future? So I'm going to use an example of some work that I did recently on Parkinson's disease. Now, this is a horrible disease that affects people generally who are older. It affects their brains. It really degenerates the brain over time, which makes people have slow movements. They walk slightly differently. They have rigid muscles and joints. And what a lot of people know about Parkinson's disease is tremors, so people start shaking a lot uncontrollably. And there's lots of different symptoms about this. And the challenge with predicting, and there's no cure for Parkinson's disease at the moment. The challenge is understanding how the disease is going to develop in individuals, because it can develop in many different ways with different people. So what we wanted to try and do was identify different subtypes of Parkinson's disease. So are there different groups of this disease that we can start to identify that we can then apply different treatments to? So we used a technique called clustering. Now, clustering uses AI to identify different groups in the data that we have. And we've seen this before. Companies like Amazon use it for identifying different buying behaviors so they can do recommendations, or Netflix use it to recommend different films to you. But what we're going to do here is identify, or try and identify, these different subgroups of Parkinson's disease. Now, it's quite easy where you got just 2 dimensions. So here's some data that we've got. It's actually footballers, and one dimension, one axis is height, the other is speed. And if you plot that on a graph, you can see generally, the shorter, faster people will be the strikers, and the slower, taller people will be the defenders. And that's quite easy to do, that the human brain can do. But what if we had 3 dimensions? And that makes it a little more difficult to visualize. But with AI, what we can actually do is move this up into tens, hundreds, and even thousands of different dimensions, and use the power of technology to try and identify these patterns and correlations within the data. So the data we had was lots of information about people's symptoms over time. And we had thousands of different patients measured over a number of different years, and at least 150 different features. So if you multiply that all together, you get a lot of data that the human brain couldn't process, but AI can. And we're able to, first of all, reduce those dimensions, the size of that, using AI, and then develop these clusters. And this is the output of that analysis. And you can see the different colored dots of different patients and how they come into different clusters. Now, that's a good starting point, but then we use another type of AI to predict what's going to happen to those people over time. So what we're able to do is predict over time how different symptoms were going to progress, and we used a predictive model to do that. Now, that's important because you can see the different colors, so each one represents one of those different clusters, and the slopes of those lines are slightly different in each one. So the ones with the steeper gradient are the ones that are going to progress quicker than the ones with a flatter gradient. And if we then plot that by cluster, you can see that one cluster here, the one on the left, has a much higher rate of progression than the other 2. Now, why is that important? Well, first of all, we can personalize treatments. So if somebody's tremor symptom, for example, is going to be progressing much faster than other people, then we can give them treatments that are very specific to the tremors. Or if it's their gait or any of the other symptoms that we talked about earlier, we can personalize those treatments. But also as well, when we're thinking about drug trials, if you're doing a trial if you're a pharmaceutical company doing a trial on a drug, what you want to do is test it on people that are going to progress faster so that you get your results quicker. So we can actually, so if you're, for example, testing a drug that you think is going to help people's tremor symptoms, then you would pick the people that were in that first cluster for the drug trial, because you're going to get your results quicker. So this is really useful information that's going to help people with Parkinson's disease either get better treatment or develop new drugs that are going to potentially cure Parkinson's disease eventually. Second question I have around AI is, can AI read minds? Now, this sounds a little bit far-fetched, but there are some really good examples around at the moment where this is starting to happen. So in this particular example, before we even consider AI, that the brain works by sending signals via the spinal cord down to the legs to help people walk. That's how we move around. But if we have a spinal injury, we break our back, for example, then those signals don't get through the spinal cord to the legs, and people are paralyzed and they can't walk. So what people have been able to do is put some computers actually connected to the spinal cord and the brain to take those signals down to the legs. So bridging that gap in the spinal cord. But that's only half the problem, because what we need to understand is, how do the legs work out what the signals are from the brain? And the answer, of course, is AI. So what people have been able to do is map the signals from the brain, feed that into AI, and get it to learn what those signals mean as people are walking around, so they can see the different patterns within the brain, and they can record those, and then they can create a predictive model that then understands when it sees those signals what it actually means to the signals going to the leg. And amazingly, what scientists have been able to do is get people who have previously been paralyzed to walk again. And this is a great example that was done recently. So you can see this chap who was previously paralyzed, couldn't walk at all, and he's got this sensor on his head which is reading the brain signals. That sends it to the machine in his spinal cord, and that then translates, the AI translates the signals to help him walk again. So he's just starting to do this, so it's quite difficult for him to do, but having people being able to walk again through the AI, effectively being able to read the mind of that person, is actually an amazing thing to achieve. Next question I have is, can AI see invisible things? Well, I think what we can do is use X-rays or MRI scans of the inside of the body to detect, for example, cancer tumours. So this is a cross-section through a human body, a slice effectively through the middle of the body, and these are the two lungs that you can see, the lung cavities. What the AI is able to do by training it, by showing it lots of images of lungs that are healthy and lungs with tumours and labelling those, the AI is able to learn what a tumour looks like. So by feeding it new images of lungs, it can then identify, in some cases better than humans, where those tumours might be. And once you can detect the tumours, then you can obviously take action to biopsy and extract the tumour from the body. So this is a really good early warning system. And it can also do it on brains as well. So this is slices through the human brain. And the AI, you can see the different coloured patterns that the AI is detecting different areas of the brain as well. So this, again, could be used for things like Parkinson's disease or brain tumours as well. The next question I had is can an AI understand medical documents, which are quite difficult to do for anybody? And here's an example of a relatively simple document that is called a clinical trial adverse event report. So when people are doing clinical trials, what they need to understand is when people have reactions to the drugs that they're not expected. So they can, when that happens, they complete one of these forms. And you can see the form has lots of information about the study name, the type of reaction it was, and then some tick boxes about what that reaction was, and then some notes, some comments at the end. So quite a lot of different types of information in that. But actually using ChatGPT, so relatively new technology that's actually available to anybody, you can feed this form into ChatGPT and ask it to summarize the document. And this is the sort of thing it comes up with. So you can see it's being able to write it in very plain English, something that most people could understand, and it's summarized all that information, including the tick boxes, into a well-written paragraph. So this is going to be really useful for doctors to help them become more efficient and to be able to, for example, explain the symptoms and the issues for patients to their family and to themselves as well. So again, a really good way of improving the efficiency of doctors. And the final question I have is can AI save lives? And I think some of the things we've seen at the moment will definitely do that. One example I wanted to give you is this project that was done by a company called DeepMind, which is owned by Google. And what you can see here spinning around is a protein. It's a representation of a protein. And proteins are the building blocks of life. And there's many different types of proteins. And what's important with proteins is how they fold determines the characteristics of what they can actually do. So it's a very complicated thing. What DeepMind have been able to do is predict what the characteristics are of particular proteins by how they fold. Now that's a really important advancement, because what it means is scientists can create new drugs by predicting the actions that they have just by using the AI. So not actually having to do lots of trials with real people and the risks that that involves, but they can actually use AI to identify the particular proteins that are going to be most useful in their drugs. And that's available now, and that's only just happened in the last few years, but this is a major advancement that's been enabled by AI. So hopefully that's interesting. It might have piqued your interest, and now you're thinking, well, I want to try some of this. I'm thinking about maybe my STEM career might go into an AI type approach. So the last question I have is, what can I do to get into AI? So one of the kind of key things is learning how to code. Languages like Python, really important, or there's R as well as an alternative language which is commonly used as well. I suggest, as well as the work you do in school, to have a look at some of the online courses that are available from companies like Coursera and Udemy. You may have to subscribe to those, but there are YouTube channels as well which provide a lot of stuff for free. One of the big challenges, though, is getting access to data so you can actually build your own models. So what I suggest is you go to a site called Kaggle, which is actually a site with lots of competitions for data science. But they have lots of data sets in there that you can download, and you can build your own AI from that using those the information from the course as well. And then finally, my recommendation is to look at Jupyter. Jupyter notebooks are a way of writing code that it makes it very clear about how you're doing it, and you can annotate your code with these, and you can share your notebooks and get help, etc. So Jupyter notebooks, they're free, and if you get those installed, then you can actually start to write your Python code in those, and it's a really useful way of learning about AI. The last thing I'd recommend as well is doing lots of reading. There's so much happening at the moment with AI. It's making all the news headlines. But there's also lots of really good newsletters around I recommend you should read, particularly my own as well, which is called That Space Cadet Glow. So if you Google that, you should find that newsletter as well, which you can subscribe to. So thank you very much for watching. I hope you enjoyed that, found it informative and useful. If you'd like to take part in any other AI related activities or download suggested resources suitable for STEM clubs at home, outside or in the classroom, then there's a couple of links there on the screen. But thank you very much for listening, and I wish you the best of luck in your STEM careers.